Hi. So in our last video, uh, what we learn how we can calculate wavelength sensitivity. So okay, we simulate for 1.44. Sorry, what was okay? We simulate for 1.41 and 1.42, and we calculate the wavelength sensitivity for 1.41. And then I told you that we'll learn today how we can calculate the amplitude sensitivity, right? So we need another row here for calculating the amplitude sensitivity. For example, the amplitude sensitivity AS, amplitude sensitivity for 1.41, right? So we'll calculate the amplitude sensitivity for 1.41. So let me tell you the amplitude sensitivity. So there you can see that this is the curve of amplitude sensitivity, and the maximum point of this curve is called the amplitude sensitivity. So here you can see the amplitude sensitivity for 1.41 is this curve is the amplitude sensitivity for 1.41. So we'll try to calculate draw this curve actually, and then for other curve you can calculate for them actually. Okay, so okay, in the paper they actually mention the equation of amplitude sensitivity actually. Okay, let me check. Okay, this is the equation of amplitude sensitivity. So let me clear it. What is amplitude sensitivity actually? So let me show some curve. So this is the curve actually. So what's the advantages and why we calculate actually amplitude sensitivity? It is very necessary to work on amplitude sensitivity. Okay, so then think about another curve like this one. So uh, for think that this is for 1.41 and this curve is for 1.42. Okay, so say let think that this is the resonance wavelength. For example, for 1.41, for example, it is at 1000 nanometer. Okay. Okay, 1000 nanometer. So at 1000 nanometer, the loss for 1.41 is kind of similar for as 1.42, right? So when for example, this is a sensor and you have some light surrounding the sensor, and light so when you will pass a light source from a laser, then it will pass all the wavelength of light, like from 400 nanometer to, so let's say 4,000 nanometer to 2000 nanometer. Okay, so from the light source will pass a light from 400 to 2000 nanometer. Okay, so uh, the light source has all the wavelength of light, right? So uh, for example, the um, and light out in the outer surface of plasmonic material, and that's refractive index is 1.41. Okay, so um, when we pass uh, when we pass the light from the through the fiber, then we will check the loss of uh, resonance wavelength. Okay, so check that the at resonance wavelength, for example, at 1000 nanometer, the loss is one kind of, let's say this is loss for example 10 decibel. Okay, decibel. Okay, let's say the loss at this point is 10 decibel. So we found that the loss is kind of 9 point, for example, 9.9 on decibel. Okay, so it's very close to 10 decibel, right? So we cannot differentiate is it 1.42 or 1.4, right? So we need a clear actually zone, right? For example, this is 1.41 and let's say this is 1.42. So at the resonance wavelength, there is a very big difference of loss, right? So for 1.41 and 1.42. So when the loss difference is very high, then its amplitude sensitivity will be very high, and then sensor will be very noiseless. Okay, so that's why we have to calculate the amplitude sensitivity. Okay, so this is the equation of amplitude sensitivity, and we have to calculate in Excel. Okay, then how you can calculate amplitude sensitivity? So okay, now I will tell you how we can calculate amplitude sensitivity. Okay, so the equation, as we've seen, this is the equation of amplitude sensitivity, difference of refractive index, and so let me get it. Okay, uh, difference of refractive index and multiply with lambda minimum and divided by lambda peak actually. Okay, so now what I can do, okay, so for that we have to calculate it actually. So the equation is and so 100 in Excel, how we can write the equation actually, it's 100 into difference from here, from this one minus this one, and divided by actually C, that will actually this one. Okay, so it's actually C12. Okay, so this is the equation of amplitude sensitivity in Excel actually. Okay, okay, enter. So okay, this is the equation. Okay, here you go. So here you can see that this is how we can calculate the amplitude sensitivity. To calculate plot the graph exactly as paper. So here in paper, they draw this curve like this. So if you want to draw the curve like this, you have to calculate. You have to simulate more data. Like you have to calculate for. Okay, you have to calculate from like 820 or 800 for 1.42, then you will get more data. Okay, and in for higher wavelength, you have to calculate more data for 1.41. Okay, then you will get more data here in this side. Okay, so this is the curve of this sensitivity. So here you can see that maximum sensitivity is um, more than 3500, and in paper this is actually, yeah, more than 3500. Okay, so this is the thing. So it's almost perfect as the paper, right? So here this is the maximum amplitude sensitivity in paper. We can check actually their maximum value, so their amplitude sensitivity. So here 300 uh, sorry, 3357. Okay, okay, it's more than paper actually we got. So no worries, it's close to the paper actually. Okay, this is the thing what we can do for amplitude sensitivity. Okay, thank you for today.